All right, guys, so one of the things I told you is I'd like to take a look at some of these exceptions or weird examples that you run across sometimes, and they're kind of the gotcha things that you'll see in science once in a while. So I'm going to give you a little story here so that you can see what happens with kind of a weird, unique situation we run into sometimes with significant figures. So, here's going to be our story about Farmer Jonah. So Farmer Jonah has got some grain, and so he harvested some grain. He's got a few acres of corn, and he's putting it into these bags that will hold about 50 kilograms, and he's driving it to the elevator. Now, most of us are suburban kids in this school district, so when we talk about an elevator, we're not talking about this thing that raises things up. An elevator is a place that's got these huge scales you can drive up onto, and it'll measure how much grain that you have, and then they put it through a dryer, and it gets in some of those big silos that they store the stuff that then are shipped out by train and stuff. So, here's this giant scale that he's going to drive up onto. So here's his truck. So here we go. Farmer Jonah gets it up onto the scale. And cha-ching, it ends up saying 3,000 kilograms. And they got this gross vehicle weight, so they look in the inside of the door, they subtract out, and they put it into the scale how much that weighs, and they'll say, okay, that's how much grain's in there, minus the mass of the truck. Well, when he was going up, you notice there was kind of a big bump. Uh-oh. So on the way up, you know, he ran over something, and unfortunately it was, well, let's just say it was a possum, okay? So hopefully it wasn't like the neighbor's cat or something. That would be horrible. So anyway, oh, and by the way, it is a myth that possums are born dead alongside the road. That's not actually true. Okay, so bad joke for the day. So anyway, a couple of his sacks of grain had fallen out. Now these are 50 kilogram sacks. So if you want an idea what that is in pounds, 110 pounds. But Farmer Jonah, being that he's worked out during the entire COVID thing, is absolutely huge, and he throws the sack over the side of the truck because he wants to, you know, get all the grain that he has, so that he gets paid what he actually brought to the market here. And he notices the number on the scale doesn't change, doesn't move at all. He's ticked. What does he think? This thing's rigged. And he sees the other bag right there, and he grabs that. Like I said, he's been working out, so he can throw this really far. Plus, he's got the adrenaline because he's getting ripped off. He's like, I'm throwing my bags of grain back on there, and I'm taking off. He throws that one on there, and all of a sudden, cha-ching, that number changes. So 3,100 kilograms, which seems kind of reasonable. That's, you know, he thought he had a little over 3,000. Well, why didn't the 50 change it? Well, this was probably like 2,930 or something like that. We threw it on there, it changed to 2,980. Something to that nature. What's going on is these zeros right here are not significant. When you get into a really big scale, it doesn't measure out there in the ones or the tens place. So these things, I don't know why it's doing that. Oh boy, this is all kinds of fun stuff. All right, we're back. All right. So it'll measure in the hundreds, the thousands, I did it again, the tens, and even the 10,000s. So this creates a problem for us. So let's go back. If we were working with that original number, what's the dilemma here? Okay, so somebody drives up there and say it's around 2,980 kilograms, it reads 3,000. Okay, we know how the scale works and stuff now. But if somebody doesn't know anything about the number, how many sig figs would you have to say 3,000 kilograms has? Where you're going to have to say just 1, because we know the 3 is significant, and we really don't know about those zeros for sure. So it could be 1, it could be 2, it could be 3, it could be 4. Now, it wouldn't be 5 because then we'd have a decimal place and a 0. There's no reason to put that final 0 to the right of the decimal unless we know the scale goes out into those kind of digits. So what do? Well, we can go to scientific notation. There's two reasons that we use scientific notation. One is in science, sometimes you have to work with really big and really small numbers. So you don't want to be writing out 23 zeros when we talk about you've got 50 grams of iron or something, and how many atoms of iron is that actually? So, you know, or if we're taking like the diameter of a nucleus, okay, now we got a really tiny number, so now I have 10 times 10 to the negative 12th or something is maybe what we'll start using for that. So how do we deal with this though? Okay, well, we can also use scientific notation to help out with sig figs sometimes. Problem solved. 3.0 times 10 to the third kilograms. Okay, that's got how many sig figs? 1, 2. There's no reason to put the 0 there unless it's significant. So unless the measuring device measures out that far. And now we don't have to have those extra placeholders because this part right here is what deals with telling me where my decimal is. So a lot of time, well, not a lot of times, some of the times we're going to be forced to have to use scientific notation because we've got what I call problematic zeros, and the only way of showing the proper number of sig figs is to put it in scientific notation. The other thing that's pretty cool with scientific notation is any of the numbers in front of the exponential multiplier are always significant. So I want to show you an example of that. We'll run into this once in a while, and boy, this is a gotcha kind of thing.